All right, kiddos, hope you're doing well. Thanks for coming to class. What I'd first like to do is watch this video, a quick review of what we did yesterday, a couple more things. And then when you're done with that, I'll have a short assignment for you to do in class together, and then you can scoot out. Have a great weekend. I won't see you tomorrow, remember, and the homework for Monday I will post on Canvas. So this is what we did yesterday, right? We're talking about polygons and angles, and we kind of work through the relationship between the sum of the interior angles, 1, 2, 3 for a triangle, 1, 2, 3, 4 for a quadrilateral, etc., etc., right? And so if we have n sides, we have n angles. And what we found was that if we have n sides, we cut that polygon into n minus 2 triangles. And each of those n minus 2 triangles has 180 degrees to it, right? So therefore the sum, meaning we're adding all the interior angles for any polygon with n sides, any convex polygon, we'll talk more about that later, is n minus 2, that's the number of triangles we cut it up into, times 180, because each triangle has 180 degrees, right? So for example, what we did yesterday is we said, okay, for a regular decagon, that's 10 sides, then all the 10 interior angles would add up to be 10 minus 2, which is 8, times 180, or 1440 degrees. Okay. Then what we did was we talked about some exterior angles. So just like a triangle, a polygon can have an exterior angle. In fact, if we have n, in this case 1, 2, 3, 4, 5, so that's a pentagon. We have 5 interior angles. Then we'll have 5 also exterior angles. 1, 2, 3, 4, 5, right? And so to get an exterior angle, all I did was extend each side, extend each side, extend each side, right? And what we noticed yesterday was that each of these interior-exterior pairs were linear pairs, right? So interior plus exterior is equal to 180, right? Also, what we went over quickly yesterday was that all of the exterior angles, 1, 2, 3, 4, 5, will all add up to be 360. And that's no matter how many sides we have. So if we have a decagon with 10 sides, all the 10 exterior angles will add up to be 360. Okay? So the sum of the exterior angles is always the same, 360, for any polygon. And the sum of the interior angles is n minus 2 times 180, right? One formula, two formulas. Okay? Now what I want to do is I want to add one little thing to what we've been doing. It's called a regular polygon. And a regular polygon has congruent sides and also congruent angles, right? So it's where everything works out nicely. So I kind of copied some below for you from a website. So a regular triangle we call equilateral, right? All the sides are the same and then all the angles are the same, right? A regular quadrilateral, if all the sides and angles are the same, would be that's correct, a square, right? Etc., etc. Regular pentagon, regular hexagon, and here's our regular octagon, a stop sign. Okay? So what we can do is with regular polygons, if they are regular, since they have congruent angles, we can therefore calculate, or we can evaluate, each interior angle or exterior angle. So we're going to move from the sum, which we talked about for any polygons of interiors and exteriors, some interior, some exterior, 360, to calculating if it's regular, interior angle, or an exterior angle. Okay? So let's think about how we can do that. So let's look at a regular hexagon. So let's look at this guy right here. Okay, and I'll redraw that. So let's suppose we have a regular hexagon. 1, 2, I'll try to draw it the best I can. 3, 4, 5, 6. Okay, that's a quick sketch. Not perfect, but it'll work. Okay, so there's a regular hexagon, meaning all the sides are congruent and all the angles are congruent, right? Now, since all the angles are congruent, and we can calculate the sum of the 1, 2, 3, 4, 5, 6 angles, then I can get one of the interior angles. So let's first calculate the sum. So the sum of the interior angles is going to be n, or 6, minus 2 times 180, right? That's the sum of the interior angle formula. So it's 4 times 180, which is 720. Okay? So right now what I know is that all 6 of those angles inside, interior angles, add up to be 720. Okay? This angle plus that plus this plus this plus this plus this equals 720. Okay? Now, since it's a regular hexagon, all of the angles have to be congruent. So all of these 6 angles are the same. So I can find out what those angles are, since they're all the same, and since I know what they all add up to be. How do you think we're going to do that? Yep, that's correct. We're going to take the sum and divide it by the number of angles that we have, right? So one of those interior angles, or one interior angle is going to be the sum, which is 720, divided by the number of angles, which is 6, right? Because they're all the same, and they all add up to be 720, right? So what we can do is we can evaluate an interior angle by taking the sum of the interiors and dividing it by the number of sides or angles, right? So to get the an interior, if it's regular, we're talking about regular polygons now, congruent sides, congruent angles. So if a polygon is regular, to get one interior angle will be the sum divided by the number of angles, which is the same as n, the number of sides, right? So for this regular polygon, in this case this regular hexagon, each of these angles is 120. Each of the interior angles, 120. Right? There are 6 of them. 120, 2, 3, 4, 5, 6. They all add up to be 720. Okay? Furthermore, if I know what the interior angles are, I can deduce what the exterior angles are. Right? What are the exterior angles? Well, the interior-exterior pairings are supplements. It's a linear pair, right? So if the interior angles are 120, the exterior angles are 60. Right? But I could have gotten that 60 in a much easier way, right? Because I know that the sum of the exteriors is always 360, right? No matter how many sides I have. So certainly for this hexagon, all 6 of the exterior angles, I'll draw them right quick. 1, 2, 3, 4, 5, and 6. There are 6 of those suckers, right? And all of them add up to be 360. So since there are 6, they're all the same. Since all the interior angles are the same, then all the exterior angles also have to be the same. So I take the sum, which is 360 of the exterior angles, and divide by 6, which would give me the same 60. So one exterior angle is going to be the sum, which is always 360, divided by n, the number of sides or angles. Okay. Okay, so here we have a kind of one more thing we can do if we know all the angles are the same, which makes it a regular polygon, and if all the sides are the same, but we're just focusing on angles. And we can find each interior angle, and if we know each interior angle, we can find each exterior angle, because they add up to be 180. Okay? All right, thanks for listening. I'm going to put the assignment on the board for you to do in class. Once you're finished with that, you can have a great day. Homework for the week will be posted on Canvas. Thank you.